For lesson 1.4, we're going to be getting deeper into functions and recursive and explicit equations. For number 2, what this is saying is when the input is 10, we need to find the output. So our function is up here, and we need to plug in that 10 everywhere we see an n. So we'll take -2 times 10 plus 1. Well, -2 times 10 is -20, plus 1 is -19. So f of 10 equals -19. You also have another one, just to keep that in mind. So here in this case, we have f of -1. So we're going to take that -2 times -1 plus 1. So -2 times -1 gives me a +2, plus 1 tells me that f of -1 is a +3. Please do me a favor and yourself a favor and box your answers just to make things a little bit easier to see. For number 4, taking that n and replacing it with 9, well, we would just have -9. That's it. That's the one. Put a box around it. Here, you're going to take the -11 and plug it in for n, so it would be -11, and we know that a negative times a negative gives me a positive, so f of -11 gives me a +11. That's it. For number 8, taking a look at it here, take that 0, plug it in for n, and when we do that, we get 2 to the 0 power. So you can plug that into a calculator and you would end up getting 1. And we're going to talk about that in more detail a little bit later, but any non-zero number to the 0 power is equal to 1. For the second part, we have f of 5. So let's take that 5 and plug it into there. And so now we're talking about 2 times 2 times 2 times 2 times 2. So 5 times. We have 4 times 4 times 2, 16 times 2. So f of 5 gives me 32. For number 10, looking at this, first we need to finish the pattern. So I noticed that I'm going down in number each time, down in value, and 11 to 9 to 7 to 5 to 3, got it. Okay, so I'm going to be subtracting 2, so I'd have 1, -1, -3. The common difference here is -2. We're subtracting 2 each time, which should help me with my recursive function. We know that my first term is 11, and that every term after that, whatever I want to find, I'm going to take the one right before it, so f of n-1, and subtract 2. For the explicit equation, we have f of n equals 11, which is our first value, plus, and in this case it's plus a -2, so instead of writing plus, I'll put -2 times x minus 1, which gives us our function that we can now simplify. So I can take that -2 and distribute it in. So 11 minus 2x plus 2. We should have f of n equals -2x plus 13. This one's a little bit tricky because of the minus. So if all you do is leave it in the unsimplified format, perfectly fine for now. just something to consider as we go through, that we're going to want a nice, concise formula to follow. So Olaf is a mountain climber, not a snowman. And what we're looking for here is his elevation at noon. So if you look, you've got 1,000, then 5,000, then 10,000 up here. And if you look in between, you've got 1, 2, 3, 4. So maybe this is 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000. So looking at this, just to clean this up a little bit, we should see that the elevation at noon is at 9,000 feet. So that's at 12 o'clock. But what about at 2 o'clock? So we start at noon and we got to go to 2 o'clock here. So we're starting at 9,000 and we end somewhere along there. And I know that it's not a perfectly straight line. If I wanted to have a perfectly straight line, I guess we could go here and see that it's somewhere between 6,000 and 7,000. So just for right now, let's say that it's 6,500. Okay. It's not completely accurate, but it is an estimate. So we want to see how many feet had he descended from noon until 2. Well, we started at 9,000 and we ended at 6,500. So you should be somewhere in the ballpark of 2,500 feet of descent. For number 16, during which half hour was Olaf descending the mountain the fastest? Where is he going to where it's going down fast? So we were going down here, going down here, going down here, going down here. What we're trying to identify here is the rate of change, how fast something changes. So up at the top, from noon to 1, he's going down kind of slow. Then 1 to 2, he's picking up a little bit of speed. 2 to 3, he's picking up more speed. 3 to 4, he travels quite a bit. He goes from close to 5,000 feet to 1,000 feet in 1 hour. Okay, he travels almost 4,000 feet in descent in 1 hour. So we can say that the 3 p.m. to 4 p.m. block of time was his fastest descent because the slope is the steepest, or the rate of change is the greatest. Hopefully this helps. Let me know if you have any questions.